MD-82 landing distances published in the airplane flight manual are predicated on the deployment of ground spoilers at touchdown and the use of main wheel brakes. Engine thrust reversers may be deployed to further decrease the landing distance, but the effect of reverse thrust is not included in the published landing distance. FAA air carrier operating rules require that the airplane must come to a stop within the first 2/3 of the available runway length. The following three scenarios illustrate a normal landing on a dry runway, a normal landing on a wet runway, and the landing made by the accident airplane. As the airplane touches down during a normal landing on a dry runway, the wings still support about 70% of the airplane's weight. With little weight on the main wheels, the brakes are able to produce only a small braking force. Once the ground spoilers are deployed after touchdown, wing lift is reduced such that the wing supports only about 20% of the airplane's weight, allowing the brakes to produce a substantially greater stopping force. In deploying the thrust reversers, the engines are brought from idle to a maximum recommended engine pressure ratio, or EPR, of 1.6. This thrust level allows the rudder to remain effective for directional control until the airplane slows sufficiently for the nose wheel steering to become the primary means of directional control. Reverse thrust should be reduced to idle as the airplane decelerates below 80 knots to avoid reverse exhaust flow, causing debris to be ingested into the engines. A normal landing on a wet runway is similar to that of a dry runway, except that a wet runway requires more distance to come to a stop. As the airplane touches down, the spoilers are deployed to transfer most of the airplane's weight to the main wheels. Brakes are applied to generate a stopping force. However, since the runway is wet, the brakes are not able to develop as much braking force as on a dry runway. In general, a wet surface has less friction than a dry surface, so the brakes will be less effective. Less friction on the wet stopping surface also means the airplane's rudder may be needed for directional control to a lower speed than on a dry runway. To ensure rudder effectiveness on a wet runway, the maximum recommended EPR for an MD-82 is 1.3. At this power setting, the reversed exhaust flow will affect only a small portion of the vertical fin and rudder. The rudder will remain effective and able to provide directional control. During the accident landing, the ground spoilers did not deploy and most of the airplane's weight remained supported by the wings. In this configuration, the stopping power of the main wheel brakes is minimized because the brakes are not able to develop the desired braking force. The small amount of airplane weight on the main landing wheels also prevented the main wheels from developing cornering forces sufficient to maintain adequate directional control during the high-speed portion of the landing. As a result, the airplane was blown to the right side of the runway by strong crosswinds. The captain tried to control the airplane by applying what would have been the appropriate rudder input. However, the thrust reversers had been deployed and the engine EPR set to near maximum value. The efflux from the thrust reversers completely blanked the vertical fin and rudder, degrading their effectiveness. With compromised directional control and little wheel friction to keep the airplane straight, the airplane began to turn into the crosswind. When the captain reduced the engine power to idle, the rudder became effective and the airplane again responded to rudder input. However, with the end of the runway approaching, the captain elected to again increase reverse thrust to almost full power. Again, the rudder became blanked by the reverser efflux and directional control was degraded. Since the ground spoilers had not been deployed, which resulted in substantially reduced braking forces, and reverse thrust was set to levels above the recommended maximum for maintaining directional control, the airplane was unable to stop and skidded off the left side of the runway, eventually coming to rest after colliding with approach lights for runway 22 left.